So this is going to be a little bit different from my other videos. This is essentially just a slideshow that I'm going to talk through just to show you a little thing that I did. So what we're looking at here is the inside of the bottom half of a Savi's Workshop lightsaber. And I'm going to start scrolling through these pictures here as I start to take it apart. You can see down in the bottom right here, that's the Rfid antenna. This white PCB contains a single RGB LED that shines a light through the hole in the base of this plastic piece, which forms the base of the crystal chamber. That LED right there is what lights up your kyber crystal from below. And then you have an orange ribbon cable here that goes down to this main logic board. And here it is removed from the housing. You can see there's the board with the LED on it. You can also see here now clearly the Hall effect sensor. That's what detects the switch turning on and off. There's a magnet in your switch, and that little device there detects it. We still have the main board here, and then we have the contacts for the battery pack, which also includes the speaker. And here's a close-up of that main logic board. The overwhelming feature here is this big blob of epoxy that is covering the microcontroller that runs the whole Lightsaber Hilt. That microcontroller contains the logic to read the RFID tag in your kyber crystal to know what color to associate with what ID, to send that signal out to tell all the LEDs to turn that specific color, to tell your blade to turn that specific color. And also it reads the accelerometer, which is this little square chip here, to detect when you swing the blade, when the blade is swinging and then stops suddenly, to know that it hit something, so it can create all those sound effects, the light effects. All of the logic comes through a little piece of silicon that is hidden underneath this blob of epoxy. And what I've wanted to do for a while now is to look at that piece of silicon and to see, is it possible to identify the manufacturer? Can I get a data sheet on the microcontroller that's in there? So a couple of months ago now, I, in an attempt to replace this accelerometer, wound up breaking my my board, and essentially this logic board is no longer functional, so it's trash. Which means, joy of joys, I have something now that I can destroy to take a look at that piece, that piece of silicon, the microcontroller, and not feel bad about it, because I've already started feeling bad about breaking the board. So I removed everything from the board, and so all I have left now is this blob of epoxy that I now need to remove. Now, when doing this sort of thing, it's usually referred to as decapping, and it's not just for these blobs of epoxy, actual computer chips, that little black squares on your motherboard. Those too can be decapped, and the standard process is the same, whether it's this blob of epoxy or the epoxy package of your the chip on your motherboard, which is stick it in incredibly nasty, powerful acids and wait. And I'm not comfortable with that. I don't have a setup to deal with acids. I don't want to. I'm not comfortable around or handling those types of things. So, is there a non-acidic way to handle this? And what I decided to do is to use a bag of dollar store sandpaper and start sanding away at the epoxy. And what you can see here is, after a little bit of sanding, I started to see these, what look like silver lines in the epoxy. These are called bond wires. They're very thin gold wires that connect the silicon die of the microcontroller to the PCB itself. And the wires will come up above where the silicon is, and then bow over onto the PCB. So I knew as I started sanding this that I would see these first, and when I started to see these, I knew I needed to start being a little more careful with my sanding. Until eventually, here's the next step. You can see what looks like it looks like two sets of bond wires. But what's actually happening is it's one bond wire. I've sanded through the top of the bow, and so now you're seeing either side of that bond wire. And as I kept going, suddenly the silicon die started to appear. And so at this point, I switched over from, I think I was at this point using like 400 grit sandpaper to a rotary tool with a polishing bit on it and a little bit of polishing compound. The idea is to remove as little material as possible. In theory, it wouldn't destroy the die. In theory. And after a bit more polishing, this is what I got. And you can see this epoxy now is very shiny. It's not wet. It's shiny because it's polished. And you can see all sorts of air pockets that are all over the place here in the thing. But most importantly, we can now see the whole exposed silicon die that is the microcontroller. And even at this in this picture, you can make out a few key features here. You can see there are two large dark areas. Those, I believe, is the EEPROM area. That's where or the ROM area. That's where all the programming goes. That's where the sound files for the different kyber crystal sounds, that the lightsaber makes. All of that stuff is stored there. The code to send out the commands given whatever RFID was read in. It's all encoded in these two dark areas here. Now, also interesting is you can see there's a big chunk of stuff down at the bottom here, but there's also a little bit up here. Now, you can see along the edges here maybe these brighter areas, and we'll zoom into those soon. But those are where the bond wires connect to the silicon die. There's a few of them also over here at the top side, and what we can sort of deduce is if we come out to this side of the epoxy blob, we go to a pair of inductors which then go off to where the speakers go. So it seems like this top end here probably has something to do with playing the audio files. There's probably a digital to analog converter here. Over here, it's not visible on this side, but if you flip the PCB over, there are markings on the PCB that show that these holes here have to do with programming the chip. There's SCA, SCK, and VPP. VPP usually stands for the programming voltage. SCA and SCK are usually part of some kind of serial interface, way to send data to and from the chip. So these three vias probably have something to do with how to program the chip. These inductors go off to these holes where the speaker used to be connected, so the programming interface and probably the audio generating air stuff is probably located on this side of the chip. And then on the other side here, this goes off to everything else, all the data pins that read the accelerometer, that read the RFID chip, that sends signals out to control the LEDs. All of that stuff seems to be on this end. So what I did is I took this exposed die here, kept it in the silicon, in the epoxy, and I put it under a microscope. And I took several pictures with the microscope, and I found a program online called Hugin, Hugin, I think it is. It's an open source piece of software, and it will stitch images together. It's used primarily for creating panoramas, but what I did is I took those images that I took with a microscope and tried to stitch them together, and this is part of what I got. We have the side of the die here that where the programming side, what I think is probably an a digital to analog converter that then connects to the speakers. That stuff is here. In fact, I would guess that these pads here and these pads here, maybe that's the speaker, or these pads and these pads could have to have something to do with the speaker. But I'm not really sure. People who are used to analyzing dies like this might have a better idea of what's going on. Here's the other side. The memory EEPROM structure I've left cut off in this image here. But you can see more pads where all the bond wires are. This area here, I'm guessing, is RAM. I'm not certain. There's this weird structure here. I'm curious to know what that is. This microcontroller didn't have an external crystal to keep its timing, so it probably has an internal circuit that generates a clock signal that usually involves like a capacitor and a resistor. I'm guessing something in here is being used to generate that clock signal. Beyond that, I have absolutely no idea what I'm looking at. But before I found Hugin, I tried making my own stitch, and here is the entire die using these pictures that I've hand-stitched together. Hugin had a problem stitching the memory area, or the EEPROM area together, so I had to do that all by hand. But now I can zoom in here and we can take a close-up look at everything that's going on in the chip here. And I can't tell what I'm really looking at here other than making some educated guesses. Maybe you have a better idea of what's going on here. But my primary goal in all of this was to try and identify the manufacturer of the chip and possibly the model number of the chip, so I could go find a data sheet on it and understand it. But the only markings that I found, you can see, are in the lower left-hand corner there. Now, luckily, the microscope that I have has a couple of more powerful optics on it, so we can look in a little bit closer and look at some of the interesting structure of the chip here. I'm sure there is somebody who knows exactly what this is, what this structure means. I have no idea at all. It just looks very interesting to me. Again, here's that weird looking, sort of like a lotus flower like shape here. I'm very curious what that is. These next two pictures are kind of interesting. It gives you a sense that there is some depth here. The way these chips are made is they're layer upon layer. They have processes where they put down a layer of a material and then another layer of material and then another layer of material, and the different properties of each layer of material create the different circuits and how they behave. So here, the top layers are more in focus, but the next picture, or the bottom layers are more in focus, but now the top layer is more in focus here. Which I thought, I'm just going back and forth between them, which I thought was kind of interesting. Now, because of how I removed the epoxy, I'm guessing I removed a lot of detail from the upper layer or layers of this chip. So there's probably extra stuff here that I am missing. Do these, what I'm assuming, are essentially wires making connections between either side here? Are they supposed to stop in the middle like that there, or did I perhaps remove them while I was trying to remove that, again, the epoxy with the polishing bit? Hard to say. More interesting structures. You can sort of see there are points where the top layers will then go down into the layer beneath and the layer beneath. And so where these pads are, where these lines end, I assume they're going down into the layer beneath them. You can sort of see these wide areas here, which I assume are carrying powers, or they're carrying power, ground, or maybe they're just a high current signal. But again, I have These are very broad guesses. I have very little understanding of what it is I'm looking at. So here's one mark. There's very little markings that I found on the die. Here's one. It looks like it says U1 to me, and it's next to a pad. Is this marking this pad as being pin 1? Or does this refer to something else? I am not entirely sure. Here's another section, and we can see some letters here. This looks like G20 and 30, and then there is a block here followed by 5 and 6. I believe there's going to be another letter over that block that either got wiped away when I was using the polishing bit, or it's a type of material that to the microscope is it can see through, so I'm not getting a clear shot of the whatever character might be there. But here in this corner is where the majority of the markings exist. You can sort of make out some idea here of what you might be looking at. Right here it says A69, and then we can see 68, and I can tell you from a different angle, I do see the letter A there. So there's an A68, an A67, A66. So I think it's counting, or it's marking the different layers of the die. That is my guess. And then the G523 and the AU11, those make me think they're related to they identify what the chip is. There is also what I believe was a G07 here that's probably been polished down a little bit, so it's smushed and doesn't look quite right. But I believe that says G07 there. I have encountered in Galaxy's Edge merchandise so far Sonic's brand microcontrollers and General Plus microcontrollers, and going online and looking at die shots that other people have made of Sonic's microcontrollers and General Plus microcontrollers, I believe I am looking at a General Plus microcontroller, the same microcontroller that does all the sounds in, or the same brand, the same company that made the microcontroller that's in Droids, that handles the personality chips. And that's my guess. I've seen in other General Plus dies that there's no clear marking that it's General Plus. I do see a G07. I do see this G20 marking. I do see this AU followed by different numbers. So I think that AU and then the number might identify the chip itself. Maybe the G is for General Plus. And then 523 could be an internal number identifying the chip. So unfortunately, I don't know exactly what chip I'm staring at here. Some General Plus data sheets contain layouts of where all the pads are on the die, and I haven't found one that matches this, but also newer General Plus microcontrollers don't seem to have data sheets that include that die layout, so I still think that this is a General Plus microcontroller, but I don't know which one. Now maybe if we go back here to like this shot here, we can see if these two cells here in the middle are RAM. You can sort of count different columns there. Let me see if I can get us in much closer. And you can see that there are these lines here with these little divots coming out, these little, I don't know what you want to call them. But if you count it up, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. So is this a 16-bit memory cell? And are there two 16-bit memory cells? Does that mean we're staring at a 16-bit microcontroller? Are they combined? Is this a 32-bit microcontroller and this isn't RAM, it's the registers? What's under this area over here that's covered in metal, essentially? I don't know. These are wild guesses at this point. So I said I wasn't a big fan of dealing with acids, but some of the stuff I read talked about how there is a sort of like a layer of glass, very thin layer of glass that goes over these chips, and that if you use like a glass etchant, you can remove that, and then you'll get better shots of what's on the die. And it turns out there are glass etching products that you can buy at craft stores to, etch your glasses, to put a pattern on them. And I thought that would be the extent of my foray into dealing with acids, was to buy a small bottle of that stuff and put some on for a little bit and see what happened. And, well, some things happened. So it turns out that I probably should have left it on for maybe 20, 30 seconds, and I left it on for minutes. And what it wound up doing is eating several of the top layers of the die. Here you can see some of the metal layers are slowly being eaten away here. It looks like something's melted through, like a scene out of Alien, It's still kind of interesting. It's exposing extra structures beneath those top layers, but unfortunately the die is now very much damaged. So here you can see this is where that logic area was, and now we see, well, I get a better shot later on, but they look like hieroglyphs. They're called cells. They're part of the structure of the chip. We'll see them in a little bit. Here in the bottom right hand, or the bottom corner here, this is where all those identifying marks used to be. They are all gone now. That G20 though is still over here, and it's happy as can be. Again, it starts to reveal some other interesting structures, like these little squiggly lines here, which I think might be resistors, but I'm not sure. This is where the EEPROM was. All that's left over now is what you see here. Again, more interesting structures here. I'm sure somebody knows exactly what they are. I don't. The area on the left here, that is where what I thought was the RAM of the memory of the microcontroller is, and you can see there's some extra structure that that was underneath the layers that were covering it before. Again, moving further left here, more of that RAM, and probably circuits to access that RAM over here. And then you can start to see that logic area earlier. It has some interesting structure. To me, they look like hieroglyphs, but my understanding, my very, very lightweight understanding, is that these form the basis for different logic elements, transistors and gates and so on, and that it's possible to sort of figure out what that logic is, what these two elements paired together like that form versus this versus so on. And you can see a lot of these forms are repeating, so you can also get an idea of what belongs together. Like, for example, this Atari symbol. You notice it's right next to these two squares, but you don't have anything like that here or here or here. So what does that Atari symbol pair with, or is it by itself? I don't know. I don't know what any of these things are, but it's very interesting, and it makes me want to try and learn more about this stuff. A closer look above that RAM area and the logic area above it. And you can see some of the metal was left behind, mostly metal around where the bond wires connect. I'm guessing it's several layers of metal, so there's more metal to eat away, so it didn't consume it all while it was being exposed to the acid. But also what was curious is off to the right here now, there looks like a couple letters here, and then the chip is cut off. This is the edge of the chip. The stuff that's over here would not be part of the chip, would be part of like testing or diagnostic utilities for when the chip is manufactured. There's a whole bunch of them on a single wafer of silicon, and then they would test each chip to figure out if it's good or if it's bad, and then they cut out the good ones and throw away the bad ones. So I wonder if LT something whatever comes after that could provide any extra clue as to what the chip is. Again, I have no idea at this point. There's a close-up of that G20 area. So that's about it. That is everything I know about the microcontroller that runs that Savi's Workshop Lightsaber Hilt. From this to this. What does it all mean? I don't know. My biggest takeaway is acid is serious stuff, and it works much quicker, even in very diluted concentrations that people will sell to you at a craft store. My other takeaway is there's not a lot of markings on here. This is probably a General Plus chip, but I don't know for certain. Another takeaway is that this mechanical removal of the epoxy to get at the die, I think, could work. I think this might be a sort of low-cost way to look at chips in somewhat. I've damaged the top layer just by using that polishing bit. If I was to do this again, I would stop here and put this under the microscope and start taking pictures to see what I can see, and I'd probably do that every like pass of the polishing bit. I'd stop and put it under the microscope so I could get a better idea of what the die really looks like before I start removing too much material. But it was an interesting experience. And that's that, I suppose. This is just something that I did because I had the broken logic chip or logic board, and I wanted to see if I could figure out what microcontroller is controlling the whole thing. I mean, that was the main motivation behind it. And then now that I've done what I've done, there's nothing more to do other than to just share what I found. So maybe you found that interesting. Maybe you know more about chip design than somebody who spent 10 minutes on a search engine. It can maybe provide some extra insight. I will create an image gallery and share the link to it down below in the description if you want to take a look at these pictures. Maybe I'll throw in more pictures into that image gallery than just these, so that way you can see all of the weird stuff that there is to see in these silicon dies. So I think that's it. Have fun.